Hello viewers, welcome back to this course. So, this is the second lecture of the scientific computing using MATLAB. So, in the previous lecture we have just started with some basics of the MATLAB. Then in this lecture also we will continue to the basics of MATLAB, and today we will talk about that how we can define the functions and how we can plot the functions, and then also we will talk about that how we can do the symbolic computation. So, let us go to the MATLAB prompt and then start doing the programming there. So, this is the MATLAB windows, this is the command windows. Yesterday in the previous lecture we have also discussed this. So, in the today we will talk about that how we can make the vectors and how we can plot the functions. So, today, let I suppose I write a function, a command x is equal to 1 colon 5. So, if I put the colon, so this is the colon sign. So, colon means this is the colon sign. So, whenever I write x is equal to 1 colon 5, it gives you the equidistributed points from 1 to 5. So, in this case, suppose I write t is equal to 1 colon 0.5 colon 5. So, that gives me the vector starting from 1 up to 5 with the subinterval having a width of 0.5. So, it is starting from 1. So, 1, 1.5, 2, 2.5, this one. So, this is used to create a mesh whenever we are plotting some function, because in this case we are dealing with numerical computation. Actually, if you see, there are two types of computation, numerical computation and the symbolic computation. So, in the MATLAB at present we are dealing with the numerical computation, means whenever I want to plot the function, I have to take the grid on x dimension in the x axis, and in the similarly I want the vectors value of the function at this grid point, and then we able to plot this function. Even I can take another variable t. So, I even define the negative increment. So, suppose I take the negative increment and 5. So, it gives me the vector starting from 10 with the increment minus 1 and then up to 5. So, it is 10, 9, 8, 7, 6, 5, and if I want to find the length of that vector, so I can define this command length of t. So, it gives you the 9, length of tt, that is the 6. Now, suppose I want to define a vector or a matrix like this one, or suppose I just want to define a function y is equal to sine. So, now I define this function on the t is the vector. So, that is the value of the function sine t given on the t mesh. So, that was starting from 1 with the subinterval length 0.5 and going up to 5. So, this is the function y equal to sine t. I can define the function on this one, or even I can define the function, another function f is equal to maybe exponential function exp over t. So, that is the exponential function. I can define the another function double f is equal to sine t multiplied by cos t. So, this is the cos t, and here because these are the two vectors, so I have to define multiply by the vector product. So, I have to put the dot here. So, now this is the value of the function with this point starting sine t multiplied by the, so this is the vector multiplication and then we multiply by the cos t. So, this is the value of the new function. Now, the same thing I can do with the help of the another function that is called the linspace. So, linspace, it gives you the linear spacing between x1 to x2 with the n number of points. So, that is the command for linspace. it means that it is creating the vector starting from x1 up to x2 with n number of points in between. So, this is the linspace. So, now suppose I define the same command and I write starting from 0 up to 1 and then I give suppose 10. So, it gives you the vector with the 10 component starting from 0 and the last element will be 1 with the 10 number of between this the 10 number of mesh points. So, starting from 0 it means it is distributing the interval between the 9 sub interval and giving you the 10 points. So, similarly I can define, so whatever we have done in the with the help of colon, the same thing I can do with the help of linspace. Maybe I can define starting from 10 and then going up to 5 with the, so in this case I will just define 5. So, that is the 5. So, starting from 10 to 5 and then I want to distribute the interval with the 5 points. So, it is 10, 8.7, 7.5, 6. Similarly, I can define the same one with the 6th element and that is the 6th element. If I go, it is 10, 9, 8, 7, 6, 5. So, it whatever the points you defined with the starting point and the end point, it will distribute linearly these points, all the sub points in between or all the mesh points in between. Now, I want to define the another function, that is log space. So, log space also they are doing the same thing. It is starting from x1 up to x2 and this is the n number of points. So, in this case it will distribute the points between the x1 and x2 n number of points with the log space. So, that is my, so suppose I want to define here. So, log space I just take -1, another one I take 2 and suppose I divide by 4. So, that gives me the value of the log space starting from -1. So, -1 means the first element will be 10 raised to power -1. So, this is the 1. Another element will be 10 raised to power 0. So, that is the 1. Another value is the 10 raised to power 1, that is the value 10 and another one is the value 2 and that is 100. So, it is giving you the mesh with the help of log space and starting from -1 to 2 and distributing the interval from -1 to 2 in the 4 with the 4 elements with the help of the log space vector. So, this is another way, but in the linear space we are getting the linear mesh, but this is the log mesh or the non-linear mesh. So, this one I can define. Now, I want to check that what are my elements here or what are the variables here. So, I can define my who. So, who will give you that what are the variable we are using in the workspace. So, this is the workspace we have. I have answer f, ff, t, double t. So, this variable I can show here in the command window by the typing the command who, and if I write the whos, so it will give you that what is the size of this. So, suppose answer is taking 1 by 1, it is a scalar, it is taking the 8 bytes of the memory. Similarly, I can define my tt, so it is a vector of the size 1 cross 6, means it is a row vector. So, suppose I take this vector. So, this shows me that the tt is the row vector with row 1 and the 6 columns, and it is taking 48 bytes in the memory and the class is the double. Similarly, I can define my y variable. So, y is again the vector, a row vector and taking the 72 bytes. So, this one we can define. Now, suppose I want to little bit go further and I want to plot. So, I want to plot the function y with respect to x. So, suppose I want to plot this one. So, this one I want to define what is the y. So, y is here and it is whenever I defined the y, I was taking the value of this y over this interval t. So, I want to plot the y with respect to t. So, this one t. So, this is the, I have to write t, this is the x variable and this is the y, that is the plot. So, this is the plot whatever we have defined for y, and what was my y here? So, y was this vector and I have defined this y when, so this y is a sin t. So, you can see that even I can define a vector linspace from 0 to 2 pi with, so suppose I do not give any number that how many numbers I want or how many mesh point I want. So, it will automatically distribute the element from 0 to 2 pi into 101. So, these are the 100 elements we are getting. So, that is the new mesh I got, and this is, I can give the name here, maybe I can clear the previous variables. So, clear all. So, it will clear all the variables that was available in the memory, and I can also write CLC to clear the screen. Now, I define, suppose that the same command I give in the previous command. So, if you want to see that how much commands you have done typed in the previous one, then the arrow, the upper arrow, you can just put the upper arrow in your computer or in your computer, then this will show you that what are the commands you have recently typed, and using this one there is no need to retype the command again. So, I have typed this command. So, this command I can show here, and let us define this one as t is equal to this. So, that is the elements we are getting. Even I do not want to show the results on this screen. So, in this case I can put the semicolons. So, semicolons, as we have discussed earlier also, that semicolon will suppress that the output to appear on the command window. But here my t is the variable, I can define that whose. So, it is the t variable having a size, the row vector this one, and taking this much of memory. Now, I define the function y is equal to sin t. So, that is my value of the function in this case. Now, I can plot. So, if I plot this one with the t and y, so that is the plot we are getting. So, you can see that this is a sine wave starting from 0 to 2 pi. Even I can define the another function, maybe y is equal to exponential t, this one, then I can plot this function. So, this is the exponential function just now we have defined. Or maybe suppose I take sin t. So, I define the another function f is equal to cos t. So, this is my cos t. Now, I want to plot. So, in this case, if I want to plot two functions together, so that is also possible. So, I will write t, but they should be of the same length. So, t y, then t f. So, this one I plot, and that is the plot. So, you can see that one is the plot for cos function and one is the plot for exponential. So, this is the exponential by the blue color, and red is giving you the plot for the f cos t. But here it is looks like that this function is a straight line, because here the magnitude of the exponential function is very high. So, that is why related to this magnitude, the cos function we know that it is always lying between -1 to 1. So, it look like a straight line, but that is not. If I just want to plot this function separately, so it is the cos function, we can see that this is the cos function we have. So, similarly I can define the another function also. Now, suppose I take the a polynomial function I can define, that I just defined a polynomial p, and so I just defined t exponential 2 plus t 2 star t plus 1. So, this is the polynomial I am defining, and then I plot this one t with p. So, this is the polynomial we are getting. So, you can define lots of functions, whatever the function you want to define. Even I can define the inverse function also. So, suppose I take a variable x from starting from 1 to maybe I can take -1 to 1 with 50 points. So, this is the this is should be semicolon. So, that is the mesh we got. So, I can define the function f double f is equal to cos or sine inverse. So, I want to define that how we can define the sine inverse. So, I can take the help functions. So, when I write the help functions, it will tell you that which type of function we can define. So, here we can define the functions. Maybe I can define sine function, or a sine means the inverse of the sine. So, let us define the function double f is equal to a sine of x. So, that is the function we are getting for a sine, inverse of the sine, and it is coming the complex here. Yeah, because so here I should define my mesh from 0 to 1, that is it. This is, it should be, so it should be 0 to 1, 0 to, so or maybe I can define this function with the linspace starting from -1 to 1 with 50 points. So, that is the value we are getting. So, this I can now define as a x is equal to this. Now, I can define my function double f is equal to a sine x. So, now I can plot this function, x with this and ff. So, that is the plot we are getting. So, this is the plot of the sine inverse function when x is defined from -1 to 1 with the 50 number of mesh points. So, this is the way we can define the function A inverse. So, similarly we can define, suppose I have now ff and I want to, so I have two type of functions. So, this now I have two type of functions, one is f, another is ff. So, I now suppose I want to define the new function now. So, I take as a another function as a q, and that is define ff dot square. So, this is the function, new function I have defined, multiply by, maybe I should define here multiply by 5. So, this is the function, new function I have defined, and suppose I want to plot this new function. So, this is the q and that is the new function whatever we have defined just now. So, that is the plot of that function. Now, even I can give the name to this plot, that what is the name of this plot. So, this plot I can give the name as, I can give the title. So, I can write help plot. So, help plot give you all this, that how we can plot. These are the plot is the linear plot, this is the x variable, this is the y variable, and then we can give that what color should be the defined for the plot. So, this is the different color we have, and this is the different styles of the plot, that how should be the style. It should be a point, it should be a circle, and this is the lines, that which line we should follow. It is a solid line, dashed line. So, all this we can define, and then later on we can also define that, like suppose I have, so this is the all the commands used for the plot function. For example, it is giving semi-log x, semi-log y, plot yy, plot 3, grid, title. So, title is the, that if I suppose I want to give the title to the plot. So, this is that how we can define the title. So, let's define the plot. This one plot I have done. So, now I want to give that it should be a k. So, that is the plot we have defined. So, this is the k. Oh, so we have to define this one in the columns. You can see that this we have to define in the columns like this one. So, that is why it is giving the error. So, we have to define this one in column, and then this is the plot we got, this is the plot. Now, suppose I want to define the title to this plot. So, I write title, and this is a column we inverted commas. So, I can write that this is the first plot. So, now you can see that the title is coming, that this is the first plot, or maybe I can define the x label or y label. So, x label means I can define the x axis. So, I can define x label. So, I write x axis. So, you can see that this is the x axis is coming. Similarly, I can define the same thing with the y axis. Y axis, and that is the. So, now your plot is complete. This is the x axis, this is the y axis, and that is the title of the even. So, all the things we can do with the help of all these commands given on the. Now, suppose I want to plot the another plot. So, plot is suppose I take the same function. So, I have to check f is defined and t is defined. So, I just want to take t and f. So, this one I plot. Now, you see that the previous plot has gone automatically. The new plot is coming, but the previous plot, because the new plot is coming on the previous plot. So, previous plot is now deleted and the new plot has come up. But suppose I want to plot the two plots on the same one, then we can define that I have done the plot 1, then I will put hold on. So, this is the hold on command, this will hold on the previous plot. Now, suppose I take the another plot t with respect to f dot square. So, instead of f I am plotting now square in the on the same plot. So, it gives you the another plot. So, you can see that it was the previous plot, and this the new plot we have plotted on the same graph by the command that is called the hold on. Similarly, now I want to again plot the same command by f divided by 3. So, this is the another plot we are getting. So, this is the third plot, because sometimes in the scientific computing we need to plot different graphs on the same plotting, or the different plots on the same graph. So, this can be done with the help of the command the hold on. If I do not want to this one, I can write the hold off. So, this will hold off. Now, suppose I want to plot any function, new function by 2. So, this plot is gone. Now, you get the new plot. So, this is the some basics commands we have done today in this lecture about that how we can deal with the graphics or we can define the functions of the mesh in the MATLAB, and how we can plot this function. So thanks very much for this. In the next one we will go for more basics of the MATLAB course. Thanks very much.